Welcome to our basic Minecraft Redstone electronics walkthrough. I'm Dr. Usual, and MD will be joining us from the real world in just a little bit. Today we're going to focus on the basics of electronics through two platforms, our virtual Minecraft world using Redstone and our physical world using Arduino. Since you're watching this tutorial, it's likely you're familiar with Minecraft already, but you may not have worked with Arduino. Arduino is a fantastic platform for learning electronics and robotics. You'll see some basic components in the presentation today, and you can find plenty of starter kits and tutorials on Amazon and elsewhere. So, let's get started. Here we've created a small Redstone work area. The server is actually set to peaceful while I'm recording, since it's really irritating to have creepers blow up your demonstration. And this area is also a safe zone, so if you play on our server regularly, you're welcome to come in here and test things out, and you won't have to worry about getting shot by skeletons or whatever else. So let's start out with some basics. We're gonna grab a couple of things that we need. Redstone lamp, some actual redstone, torch. That should do. We're going to make sure it stays daytime. And here we'll get started. First, to create a redstone mechanism, we need two things at an absolute minimum. We need to have a source of power and we need to have a load. By load, we mean anything that actually consumes power and ideally does something. Technically just moving the power around can mean you're putting load on a wire, but that's not really accomplishing anything. So for this tutorial, we're going to refer to a load as something that actually consumes power and accomplishes something. So as an example, this redstone torch is a power source. There we go. And this redstone lamp is a load. If you haven't used a redstone lamp before, if you can't guess, what's going to happen is that when we actually power that lamp, it's going to light up. So, a third element is almost always present, but it's not 100% necessary. That's a transmission channel or some way to move the power around. To keep things simple, we're going to refer to it as a wire. And here in Minecraft, we create wires by using redstone dust. We'll put that right over here. There we've created a wire that is 3 blocks long. Now, I'm not including the redstone dust as a required element because it is possible to just set the source directly on or next to the load in some cases without an actual wire in between. For example, let's just put a source here and a load there, and you can see that that torch is actually powering the adjacent block and hence the load, the lantern. But more often than not, you're actually going to have some wire in your creation because you won't have everything right next to each other. So let's take a look at a really simple example. Here we have a source, a redstone torch, and a few blocks away, we're going to put a load, a lamp. Then if we run wire in between, you notice that this wire is bright red and is actually giving off little smoke or energy bursts here. That means that it's actually powered, as opposed to that wire that's still dull and inert. It's not doing anything. No power. And if we run that wire all the way there we have it. The source transmits power to the load and the lamp lights up. So before MD shows you how this works in the physical world, let's ask some cows for some help in remembering the concepts. Oh. As you can see over here, my cows have no water. There's a way for them to get some water, but there's no water in there, which means they're probably not very happy cows. Up here, we have a water supply. Now, in both the real world and in our Minecraft world, Electricity, Minecraft, Redstone, they both behave a lot like water. So this is a good way to remember how your Redstone design is going to work, or how your electronics design is going to work. First, we've got a pool of water here, and we'll pretend that that's a power source. So let's put a sign here. Let us know that's our source. And it's a source just like a redstone line. Now we have a channel coming down here where the water could potentially run. That is very similar to our redstone wire, right? That's going to be our wire. And then down here we have the load, which in this case is a bunch of cows, or more specifically, it's the pool from which the cows can drink. So all we have to do to get the water down there is take out this piece. Now we have a complete wire or channel going down there to the pool. And now our cows are going to be able to drink. So, whenever you're planning a redstone project or a real-life electronics project, just remember you have to feed the cows. And if you can't figure out why you're not getting the results you want, why your redstone lamp hasn't turned on, or why your piston isn't moving, or whatever, just ask yourself, if I look at this whole design, am I going to be able to feed the cows?
Hi, I'm MD Usual, and I'm going to show you how to recreate the Minecraft redstone circuit in real life. We need the same components as used in Minecraft, so for our power source we have this battery, and for our load we have this LED light. The legs of the LED are essentially a wire, so if we connect them to the battery, instant redstone lamp. Here's another example. I put this circuit together with a breadboard, but it works almost exactly like the one you just saw. First, we have a power source, a battery. We also have an LED. In between, we have some wires. Remember, in many ways, electricity behaves like water. Once I connect the wire between the LED and the battery, the electricity can flow, and we have happy cows.
Welcome back to the Minecraft world. Now we know how to power a redstone lamp or a real LED from a power source, but we don't want to waste energy by leaving the lights on all the time, so we need to add something that you should recognize, a light switch. A basic switch is a pretty simple device. You can think of it as a break in the wire, a break that you can fix whenever you like. So over here we have a redstone wire, but it has a break in it. And you can see that the wire on the left is powered, while the wire on the right is not. When the switch is open like that, there's an empty space and the power can't flow. But when the switch is closed, the wire is complete. And now the power flows to the device. Now, redstone levers actually provide power themselves. You can think of them as a switch with a battery inside, so we don't need a separate redstone torch. We can simply place a lever, place some wire, place a device, and when we turn it on, the power flows. Of course, redstone has other types of devices, including my favorite, the sticky piston. If we come over here to our water supply, we find that the piston is attached to a stone block. And as long as the power is on, the piston is extended. When I turn the power off, the piston pulls back the block, And now the water can flow all the way down to the trough, and as you guessed it, we have happy cows.
Welcome back to the real world. Here we have almost the same circuit as before, but just like in our Minecraft example, we want to be able to turn the circuit on and off. Just like before, my circuit has a source and a load. There are wires in between, under the table, and just like in our Minecraft circuit, we've added a switch. Turn the switch on, and the power flows. And you guessed it, happy cows.